Today's lesson, section 1.2, we'll be talking about exponents and radicals. So here's just a brief description of all the exponent properties, and also we'll go through all the radical properties. So exponent properties, where if you have two bases that are like, so they have the same value or the same variable, and you have two different exponents, and you're multiplying them to each other, then you can combine them by adding the exponents. Vice versa, if you are dividing like bases with different exponents, then you would subtract those exponents. For the third one over to the right, that top line, if you have a base with a negative exponent, then that's the same thing as moving that base down to the denominator of a fraction, because right now it's really a to the negative n over 1. And you can move it down to negate the negative, so it makes it 1 over a to the nth power. Second line, first one on the left, so it says that it's called the power property. So if you have a base with a power to another power, then it's like you're multiplying the two powers. So m times n would happen in the exponent. So if like m was 3 and n was 4, then you get a to the 12th. Additionally, if you have two bases to the same power, then they both get that power. That third one to the right, same thing. If you have a division of two bases to the same power, they both still get that same power. So it's a to the n over b to the n. And then same thing with the a to the negative n power. When you have a denominator, or like a fraction, to the same power of negative n, then that negative flips them, so the a would move down and the b would move up. So it's kind of like a flip, and so then that negates the negative, so it makes it b over a to the nth power. And vice versa, if they have, if you have two things in a fraction that both have negative, or one or individually, then the one on the bottom moves up, the one on the top moves down, and they lose their negative. And then also the last one on the right, third line, anytime you have any base to a 0 power, it is always equal to 1. Okay. Now, here we have the definition of an nth root. So if n is any positive integer, then the principal nth root of a is as follows. So you have the square root, the nth root of a is equal to b, which is the same thing as if you took both sides by the n power, then you would get b to the n is equal to a, because the nth power cancels out the nth root, but you have to do it to the other side, so the b gets to b to the nth power. Okay. If n is even, we must have a is greater than or equal to 0 and b is greater than or equal to 0, because you can't have a negative value underneath an even root, because then you have imaginary numbers, which allows it not to work. Now for the radical properties. Here, if you have two bases that are to the same nth root, you can also split them up. So vice versa, if you have two bases to separate, but they're the same root, so like if there was the square root of a and the square root of b, because they're the same nth power, then you can combine them, so the same indice, then you can combine them back to be under the same one. Okay. Vice versa, if it's a division problem, so the nth root of a divided by b, you can still separate them, so the nth root of a over the nth root of b. Here, if you have a to the 1 over nth power, so this is a rational exponent, the n is actually describing your index, or your nth root, so we can revert that back to a radical. So that's kind of our tie to be able to go from rational exponent or exponents to radicals, and back and forth however we see fit. Second line, the first one there, if you have a root like mth root and then inside is another radical, then you can actually multiply those two, because it's kind of like saying a to the 1/nth power. Maybe writing this out would make a little bit more sense. So the a to the 1/nth power times 1 to the nth 1 over m power. So since the power property says that I can multiply, you can multiply those bases, and then using this property up here, you can revert it back to a radical situation. Also, if you have a to the m over n power, the 1 that we previously had just tells me that there's 1a. So really we could say that this is a to the first. So now, this is just saying if m is some other number other than 1, then I have m of them underneath the nth root radical. Okay? And then the last thing is if n is odd, then when I take the nth root of a to the n, that's just going to be a, whatever a is, whether it's positive or negative. If n is even, then the nth root of a to the n is going to be the absolute value of a, because a is a variable, so we don't know what the value is of it. But if it's negative underneath a even power, that's where we get our our imaginary values that we don't want or can't have in the real number world. So we need the absolute value there to negate that. So here the next thing is, example 1, we want to be able to simplify the following expressions. So letter A says a to the third times a to the fifth. Now because the bases are the same, that means we use our product property, where we take the 3 and the 5 and add them together to get a to the 8th. Here, for letter B, when the bases are the same, b to the 6th divided by b to the 4th, that means we would subtract our exponents. So 6 minus 4 gives me b to the 2nd. Okay. Letter C is a power property, so x squared to the 8th, that means I'm going to multiply my 2 and my 8 to get 8 or x to the 16th. And then D is just an extension of the power property because there's multiple things inside the parentheses that get that power. So x squared gets to be multiplied by the 4, and then the y cubed gets multiplication of the 4. So then I get x to the 8th power times y to the 12th. Letter E is doing the power property but with a quotient. So the 10 gets to go to the 10, and then it also gets to go to the 2, so it's p to the 10 times 10 power over n to the 2nd times 10 power. So then that's p to the 100th power over n to the 20th power. Now letter F is just using the negative exponent, and now usually when we have a negative exponent, we don't want it, so we need to move it down to the denominator. So remember that it's over 1. So this negative sign makes this whole entire base with the exponent move down. So it's going to be 1 over x and to the positive 5th. So the act of moving it down makes it positive exponent. Okay, it doesn't make the base positive, it makes the exponent positive. Letter G. Now here, you're doing kind of like what we did for letter D, where you have some bases inside the parentheses to a power, but because the power is 0, that means the entire thing is equal to 1. Letter H, first is you have a negative exponent, so that means we need to use our property that we saw before, where if it's negative outside a quotient, they both flip, so then b to the 3rd moves to the top, and then a to the 2nd moves to the bottom. And now it's to a power of 3 instead of a negative 3, but just like what we did for E, the 3 goes to the exponent of 3 for b and to the 2. So then I get b to the 3 times 3, which is 9, and b to the 2nd times 3, which is 6. Letter I. Here we're taking the 4th root of 81 to the x to the 8th and y to the 4th. So here, if I want to simplify this, I kind of break it up into two pieces, or several pieces. So I can say the fourth root of 81 times the fourth root of x to the 8th times the fourth root of y to the 4th. Okay, so here I know that 81 is just 9 times 9, which is 3 times 3 times 3 times 3. So this is the same thing as saying 3 to the 4th, and because it's 3 to the 4th, the fourth root of 3 to the 4th would be 3. Okay. Here you have fourth root of x to the 8th, so there's two sets of x to the 4th in that, so then that could be x squared. And then the fourth root of y to the 4th is y. Now, what we said earlier in the radical properties is that if you're taking the nth root of a to the n, and it's even, then you have to have an absolute value around the thing. Now, x to the 8th was even, okay? But because you got x squared, you don't need the absolute value, because the absolute value just makes it positive. The act of having an x squared, it's going to make it positive anyway, so you don't need the absolute value around the x squared because it would just be redundant. But because y is just to the first, that means we still don't know what y is, so it could be negative or positive, but it can't be negative, so it has to be positive. So because we pulled it out, we need to have the absolute value signs around the y value for letter I. Letter J. So here I can split it up and say the fourth root of 16 and the fourth root of 81. I've already seen what the fourth root of 81 is from letter I, so I know that's 3. Looking at 16, if I did my factor tree, I get 4 times 4, which is 2 times 2 times 2 times 2. So that's the same thing as 2 to the 4th. So because it's 2 to the 4th, the fourth root of 2 to the 4th would be 2. So I get 2/3. Now notice I don't have to put absolute values around the 2/3 like I did for the y, and I don't have to do it for the 3 and I. It's because we already have that number established, and you already know it's positive, so you don't need an absolute value to make sure that it's positive because it already is. So it's not necessary to put it. It's only putting it around variables because we don't know the value of them. So that's why we had it around y. Letter K. Here you have a negative exponent, a negative rational exponent to be exact. So first, I need to deal with my negative exponent. So I move the 125 to the 1/3 to the bottom. Now here I'm going to change it to radical form because it might make more sense when I'm trying to simplify this. So the 1/3 power is actually the third root of 125 to the first. And so here, 125 is 25 times 5, which is 5 times 5. So altogether, that gives you 5 cubed, so the cube root of 5 cubed is 5. So I get my answer of 1/5. And then last one, letter L, we have the square root of x times square root of x inside. So here, if I want to use some rational exponents to help me out, because usually rational exponents are a little easier to deal with, so I'm going to put a big parenthesis around it. Now, since it's square root, remember there's no number there, so you're probably thinking, what's that number? Well, it's actually 2. Same thing for the one on the inside. So it's actually to the 1/2 power if I changed it back to a rational exponent. And so then I have x, and then times x to the 1/2 power. Okay? So because you're multiplying these like bases, on the inside here, I can actually add them. So 1, it's x to the first, which is the same thing as 2/2. So I actually get x to the 3/2 when I add them. And now you have power to power property, so you can multiply those two, which gives you x to the 3/4. Now you can choose to rewrite this back to a radical, but you could leave it as a rational exponent unless suggested otherwise. So the radical would be the fourth root of x cubed, but having it like these, either would be right. Okay, so either could be your answer. All right, have fun.